Hello friends, once again we are meeting to study the new chapter titled Hydrostatic Pressure on the Surfaces. Now in this chapter we will study the total pressure, center of pressure, then pressure acting on the immersed lamina in vertical position as well as the inclined lamina position. Then we will study the pressure on the lock gates and the pressure on the gravity dams and the stability of dams. So these aspects we are going to study in hydrostatic pressure, and after that, side by side, we'll also go through some numericals asked in the university examinations, public service commission examinations, and the gate examinations. So let us begin with our new chapter, that is hydrostatic pressure. Okay, so we'll start our lecture. So let us begin with the chapter number 3, hydrostatic pressure. Pressure on lamina immersed in a liquid. Now let us assume that you are standing in a room and there is no window, there is no door, and suppose there is a complete field of water. That room is completely filled of water, and you are standing alone in that room. So whatever the pressure exerted by the water on your body, that is the total pressure, and the point where that total pressure acts is known as the center of pressure. Now let us begin with our chapter, pressure on lamina immersed in a liquid. Now consider a lamina of area A immersed in a liquid whose weight is W. Consider the elemental area dA. Now consider the elemental area here dA, that is 3.1 pressure on lamina immersed in a liquid. Consider lamina A. Let us consider this is lamina A whose specific weight is W. Okay. And consider the elemental area dA. Let us say this is the elemental area dA here, situated at the depth y below the water surface. Situated at y below the free water surface. Now the intensity pressure acting on this lamina is equal to P is equal to W specific weight into this height. Okay. So therefore the pressure force on the whole lamina is equal to P is equal to summation of W into y into small elemental area is dA. Okay. Now W is constant, so let us keep outside. Then summation of y dA. If we sum up this entire y1, y2, y3 and dA1, dA1, dA3 like this way, so it will be total will be y bar. Okay, and total area is A. So P is equal to W into A y bar. This is the total pressure. So what is y bar here? Y bar is depth of centroid of the lamina from free water surface. Capital A is the total area and W is the specific weight of water, and the P is equal to total pressure force. So let us begin with the definitions: total pressure and the center of pressure. So total pressure, when the static mass of a fluid comes in contact with the surface, whether it is a plane or whether it is curved. So force exerted by the fluid on the surface, this force is known as the total pressure. Since the fluid is at rest, it is stationary. So therefore there is no tangential force exists. But the pressure acts in this direction is normal to the surface. So next definition is the center of pressure. Center of pressure is defined as anyone or on any surface, the intensity of pressure is not uniform. The pressure intensity at any point depends upon the depth and the point below the free surface. The resultant pressure P on the immersed lamina will act at point C, somewhere point C. Let us say this is point C here, below the free water surface. So here it is C. So this point where the resultant pressure P acts is known as the center of pressure, which is denoted as C. Now let us consider the first case, that is center of pressure immersed in a vertical lamina. Okay. So let us consider elemental area dA here, at a depth y. Now what we mean to say here, if the pressure intensity of the lamina had been uniform, the resultant pressure would be at center of the lamina, means at this particular position, that is center of the lamina. But this is not so. But the pressure intensity is greater at the greater depth. As the depth increases, the pressure intensity is also increases. The depth of pressure also increases. So the resultant pressure P will act at new point, that is C, that is below the centroid of the lamina. Now let us understand one by one the nomenclature. What is H bar? H bar is the depth of center of pressure. A is the area of the whole lamina. Y bar is the depth of centroid of the lamina below the free water surface. Means Y bar is this depth of the centroid from the free water surface. Now consider the elemental area dA. Let us consider this elemental area dA here at a depth Y here. Okay, below the free water surface. Below the free water surface. The intensity of pressure acting on this particular point or acting on this particular area is equal to P is equal to W into Y. Therefore, the pressure force on this elemental area is intensity of pressure into area. So, force is equal to pressure into area. So, P is equal to Wy into dA. So, therefore, the moment of this force about the free water surface is equal to Wy into dA into Y. Because force into distance is the moment of this force. So, this is Wy, dA is the force and the distance Y. Therefore, the moment of total pressure on the lamina about the water surface is equal to W into IO is equal to summation of Wy square dA, where IO or I0 is moment of inertia of the lamina about the line of intersection of the water surface and the plane of the lamina. So, therefore, total pressure P is equal to W into A into Y bar. W into A into Y bar. Now this P acts at the center of pressure, means where this P will act at center of pressure, means at this particular point. Okay. Then therefore the moment of total pressure above the free surface is given by P into H bar, means where this force act at H bar. Where this force act at, it is acting at H bar. So P into H bar means total pressure P will act at this particular point. So P into H bar into W into AY bar. So P is equal to W into AY bar into H bar means P is equal to W into AY bar. So W into AY bar into H bar is equal to W into IO. Means we have already discussed here W into IO. Okay. So H bar is equal to IO upon AY bar. Now let us consider IG. IG is the moment of inertia about the centroidal horizontal axis of the lamina. And we know that the parallel axis theorem we have already studied in our junior college 11th or 12th and in first year also in mechanics. So H bar is equal to IO upon AY bar means we have arrived from this particular point. IO is equal to IG plus AY bar square. So this is by parallel axis theorem. So therefore H bar is equal to Y bar plus Ig upon AY bar. So this is the depth of center of pressure is equal to the depth of centroid of the lamina from free water surface plus moment of inertia about the centroid upon total area into Y bar. So H bar is equal to Y bar plus Ig upon A into Y bar. Now let us consider case number 2 here. Now instead of vertical lamina, we will consider here inclined free surface. The immersed lamina inclined to the free surface. So consider figure this. So instead of, if we see it is immersed lamina with making an angle theta. Okay. So let H bar is the depth of center of pressure. As usual notations, A is equal to area of the lamina. Y bar is the depth of centroid of the lamina below the free water surface, that is liquid. Consider the elemental area dA, which is this area. If we take first angle position, we will see this is dA. Okay, so dA at depth y, Okay, if we see the plan like this way, so it is Y bar, and this is the section view, and this is the plan. So Y bar, Y bar is the depth of center of the lamina below the free water surface. Consider the elemental area dA here. So at depth y below the free water surface. And what is x? X is the distance of elemental area from the line of pressure acting on this elemental area from the line of intersection of the plane of the lamina. Means this is free water surface and this is the plane of the lamina. So this makes an angle theta, and this dA is located at distance x. Okay, so this is the x, the distance of elemental area from the lamina, from the line of intensity of pressure acting on the elemental area from the line of intersection of the plane of the lamina that is inclined to the free water surface. Now, as usual, P is equal to total pressure on the lamina is given by P is equal to W into A into Y bar. Therefore, in this case, the pressure force on the elemental area dA, it is P into Y dA and W into Y dA, which is x sine theta. So Y is x sine theta. So this component will take normal to the free water surface. Okay. Therefore, the moment of this force about the free water surface or the liquid surface is equal to W into dA into x theta into x. That is force into distance, that is x. So force into distance. So this is force and this is distance. Therefore, the moment of total force about the free water surface or the liquid surface is equal to summation of W into dA into x square theta. W into dA into x square into theta. So therefore, total pressure on the lamina about the free water surface or the free liquid surface is equal to W sine theta summation of W into dA x square is equal to W sine theta into IO. As usual, we already derived this equation in case of vertical lamina. So let us IO or I0 be the moment of inertia about the line of intersection of the plane of the lamina and the free water surface. Let here it should be C. C be the center of pressure and H bar is the depth of center of pressure. Then CO is equal to H bar upon sine theta. So CO is equal to CO is sine theta. H bar upon sine theta. H bar upon sine theta. Okay, the moment of total pressure on the lamina about O is equal to total pressure into H bar upon sine theta. So that is W into AY bar into H upon sine theta. So W into AY bar into H bar upon sine theta. So W sine theta is equal to I O or I0. H bar is equal to IO AY bar sine square theta. So sine theta sine square it will be sine theta into sine theta sine square theta. Then let Ig be the moment of inertia about the centroidal axis in the plane of the lamina parallel to the water surface. OG be the distance between the centroid and O in the plane of the lamina. Y bar upon sine theta is equal to Y bar cosec theta. Using parallel axis theorem, IO is equal to Ig plus A into AY bar cosec theta whole square is equal to Ig plus AY bar square cosec theta square. Okay, substituting the above expression in terms of H bar. So H bar is equal to Ig plus A into Y bar square into cosec theta square upon AY bar into sine square theta. So H bar is equal to Y bar plus Ig upon A into Y bar sine square theta. So this is the center of pressure when it is acting on the immersed lamina. So H bar is equal to Y bar plus Ig upon AY bar sine square theta. What will happen if the theta is equal to 90 degree? So it will be 1. Sine square 90 will be 1. So this lamina will behave like a vertical lamina. So make a note here, if theta is equal to 90 degree, so therefore sine theta is equal to 1. Thus in this case, it will become a case number 1, that is center of pressure on the immersed vertical lamina. Okay, so let us conclude this our topic today, and tomorrow we will take some numericals on this particular subject. Before concluding today's lecture, let us have a look over the geometric properties of different laminae that we are going to use in the subsequent lectures, namely rectangular, triangular, circular and trapezoidal and square also. Please note down their respective area and the distance of centroid from the free water surface or free liquid surface. Let us today will conclude the lecture. Thank you. If you like the contents of this lecture series, Please give like, and please do comment in the comment box, and please subscribe the channel if you are new to this particular channel, if you like it. Thank you. Please cooperate and do subscribe this channel.